In this video, we will solve some problems relating to standard error of the mean, and here is the formula. First formula is for population standard deviation, and the second formula is for sample standard deviation. So let's first solve a problem. Sample standard deviation is 3, random sample is 144, and the mean is 5, and we want to find the standard error of the mean. In this case, since they give us sample standard deviation, we have to use this equation right here. So we will say that the standard error for the mean is equal to the standard deviation. Here it says it's 3 divided by the number of terms. We have 144 samples, so divided by the square root of 144. So we get 3 divided by 12, which is equal to 1/4, which is equal to 0.25. So the standard error of the mean is 0.25. In the next slide, we will go over a visual representation. So this bar graph right here represents the mean. We have 5, and it says 5 here. The mean is 5, right? Now, in order to visually see the standard error of the mean, we have 0.25. So it goes up to 5.25, and it goes below 4.75. That's essentially the standard error of the mean. Now we have another problem. Population standard deviation is 3. We have a random sample of 144. It's the same thing, but we're using this equation here. So 3 divided by the square root of 144, 3 over 12, is equal to 1/4, which is 0.25. So standard error of the mean is 0.25. When you randomly selected samples of n is equal to 144, then the average difference between the sample means and the population mean is 0.25. Now, why is standard error of the mean important? Now I'm going to go over an example to show why. Say you have two sets of number. Set 1, 0, 5, 10. In this case, the average is 5, right? If you do 0 plus 5 plus 10 divided by 3, you get 5. Now you have another set, 5.1, 4.9, 5.2, 4.8, 5.3, 4.7. If you use a calculator, you would get 5. So which set of data do you think would have a lower standard error of the mean? If you want, you can pause the video and think about this. So this was our standard error of the mean equation. So if you want to have this number to be low, you want to have a lower standard error, you can have a couple of options. You can either have a small standard deviation, or you can have a large number of samples. So in example for set 1, sample standard deviation is 5 and only has 3 numbers. However, if you were to calculate the sample standard deviation for this set of number, it would be 0.237 and has 6 numbers. So clearly set 2 would have the lower standard error of the mean. And visually, if we were to look at it, so we did 5 divided by the square root of 3 numbers, we get this value. We said the mean was 5, but now our standard of error is going to be 2.887. So up to here, up to here. However, with set 2, we had 0.237 for our standard deviation, divided by the square root of 6, we have 6 numbers. This is our standard error, which is this small piece right here. And so that's pretty much what standard of error of mean can look like.